Hi there, in this video we'll be looking into a problem called product of array except self. Let's jump into the problem statement. So given an integer array, return an array such that answer of I, each element, is equal to the product of all the elements of the given array except the element itself. Okay, so the product of any prefix or suffix of nums is guaranteed to fit in the 32-bit integer. You must write an algorithm that runs in order of n time and without using the division operation. So the problem statement is straightforward. We are given an array, right? At every index we have to find out what is the product of the entire array, not including that particular index element. So if you take 1 here, without including this one, what is the the product of all the other elements, 2, 3, 4. So here in this case with 2, without including 2, what is the product of all the other elements, which is 1 into 3 into 4, which is 12. Here for 3, without including 3, what is the product of all other elements, which is 1 into 2 into 4, 8. The same way 6. That applies to this as well. So the conditions given which are given to us is that we don't have to worry about integer overflow, and it is guaranteed every sum, every product at a particular index will be of 32-bit. Cool. And also we have to look for an algorithm where the solution is of order of n time complexity, and we should not use division operation. So this is a bit highlight here, because one solution which comes to our mind straight up is that we traverse through the entire array, we obtain the total product, then at each element we divide the total product with the current element. That gives what is the product of all other elements. That is one of the easy solution, but the requirement given to us is we should not use that approach, right? And length, okay, the usual constraints, and numbers also the usual constraints, and right. Also there is a follow-up question. So if we can solve this in order of 1 extra space complexity, right? Okay, let's solve this with keeping in the mind of order of n time complexity. We can optimize the space complexity later. So if we take the example given to us, like something like 1, 2, 3 and 4, at each element, excluding this, we have to include all the other elements and put a product in this element. The result array should have product of all the elements in the array except that particular index element. Here it will be 1 into 3 into 4. Here it will be 1 into 2 into 4. Here it will be 1 into 2 into 3. This is the result which we are looking for, right? So one approach which we can think of is that when we are at this element, what we are essentially looking at is product of all these elements and all these elements. In this case it is first index, so there is no prior elements. But if you take this one, if you take the example of 1 in this 4, this particular thing, the result of this particular index is the product of this and product of these. There can be more also here. If it is a big array, there can be 10 elements here, 10 elements here, right? So the result of this particular index is product of this one and this one. So what we can think of is, right, so initial approach we are not going to bother about the space complexity. So what we can think of is, we can think of having two arrays. One is prefix product and suffix product, right? Prefix product and suffix product. We traverse through the array. At each element we say what is the prefix product. The prefix product of 1 would be, initially there is no element, right? So we start with 1. For this one the prefix product is 1, correct? For this one the prefix product is 1 into this one, which is 2, right? The prefix product for this one is 2 into 3. what is the current prefix sum, because the prefix sum here is till here, right? To get the prefix sum, prefix product for this one, we have to multiply this whole thing with 3. That gives us 6. This is our prefix array. Suffix array will start from this start, because when we traverse this way, we will be multiplying this. We have to come this way, right? So for 4, there is no element, so we start with 1. For 3, it is 4. 4 into 1, which is 4. Here 4 into 3, which is 12. Here it is 12 into 2, which is 24. Our result is nothing but, at this element, what is the result? It is nothing but prefix product into suffix product, right, which is 1 into 24, correct? So our prefix has this whole product, our suffix has this whole product, right? Our result is nothing but prefix into suffix, right? Makes sense, right? This is one simple approach. Let's solve this, then we see how can we optimize this. Like, I know this is, we are using the space complexity is order of n again. Let's see how can we make it better. Let's just first solve this, right? So initially, let me take a result array, so which is new int, and let me have the length of array as L equal to nums dot length, right? Let me put it here. Now let me have two more arrays, right? One is my prefix and one is my suffix, correct? Let's populate this prefix first. So we have to, initially the first element of suffix would be 1, right? So we are starting from I equal to 1 to I less than L and I plus plus, correct? So now suffix of I is equal to suffix, we are starting from 1, so we have to take suffix 0 value, and what is the element present in the array at 0th index, because in this suffix 0, this number is not included, right? So we have to include I minus 1 to get ith suffix product value, right? So this populates the suffix product. So, and prefix, in between I think I am saying sum, excuse me for that, I meant product there. So in this case it is L minus 1, correct? L minus 1, we are starting from 0, and here I we can take, we are starting from L minus 2, and we have to go till greater than or equal to 0, right? Greater than or equal to 0, and prefix of I is equal to I plus 1, right? Prefix of this, and nums, what is the value at I plus 1? What is the next element present? I minus 2, what is the element at I minus 2 plus 1, which is I minus 1. So this will populate our prefix. Now we have to iterate one more time, right? From I equal to 0, we have to iterate till I less than L, and we have to increment I plus plus, and our result, right? Our result I is nothing but suffix I into prefix I, right? And we have to return the result, right? Okay, if you observe here, we don't require this result actually, because if we remove this result, we can directly update our nums itself and return our nums itself, right? We don't require that additional array to be maintained just to give back the result. Let's run this. Okay, the test cases are accepted. So let's submit this. Okay, so this got submitted. This is cool, right? This if you observe here, this is fine, this solution is fine, but it's just that we have this extra space complexity which we have, which we will try to avoid. If you observe here, what we are trying to do is we are trying to maintain a prefix array, then suffix array, then getting like updating the product into our result, right? Instead of maintaining this, let's take result itself, right? Now instead of taking suffix, right, I'll take this as a variable, okay, and what I do is I'll update my result itself. Okay, I'll update my result itself. So my result is equal to my suffix. First what I'm doing is I'm updating my instead of maintaining this array, I'm updating it into my result itself. So once I update the suffix here, I have to update, this will be 1 for the first element. For 0th element, suffix value is 1, right? First element, the suffix value is 1, right? When we are here, this will consider this suffix and this element, this element, correct? So we have to update the suffix as well, which would be considered for the next element. Suffix is equal to result of, we can start from 0 itself here, we can start from 0 and we can update the suffix here, right? And so 0 suffix would be 1, right? For the next element, we are calculating the suffix, right, where we are updating the current suffix with the current element itself, right? Current suffix with current element, such that it gets assigned to the next element result. Okay, so we'll follow the same thing for prefix as well. It's just that we will be coming from that side. Now our result would have got all the suffix. To the suffix we will be multiplying the prefix. So we'll start from prefix, we'll start from the last element, right? Last element, we have to multiply our result of I would be, result of I would already have suffix into 1, right? Would already have this suffix value, right? To that I have to multiply the prefix, correct? So the last element, what I mean by that is, for the last element, if you take this last element, okay, here I am already holding the suffix in my result. If you take something like this, right, my result, he's holding my I'm taking, this is my prefix actually, this would be, sorry, my bad, this is my prefix is the previous one, I think for the last one I named it incorrectly. That's fine. So this is suffix. Suffix is this one, prefix is previous value, right? So what I'm trying to say here is, for 1 it is 1, for 2 the prefix value is 1, for 3 the prefix value is 2, for 4 the prefix value is 6. Now I am starting from here, okay, to what I am doing is I want the result to be present. So what is the suffix value for this? It is 1, right? So I have a suffix temporary variable where I am storing it as 1. So I'll get in my final result as 6. When I go here, my suffix value would become 1 into 4, which is 4. So for this 4, for this 2, which is a suffix value, prefix value, I am multiplying my suffix value, which is 4 into 2, 8, right? My suffix value will become 8 here. Sorry, this would be, here the suffix value is 4, right? Here this would be 12. This will become 12 because we have to include this, right? This 12 gets multiplied to my prefix value, right? My suffix then will become 24, which will be multiplied with my prefix value, which is 24, right? So here, so my suffix is starting from 1, my result is updating with my current result, which holds the prefix, for which I am multiplying my suffix, right? Then I have to update my suffix with current suffix into my current value, which goes for the next element, alright. So here I need a duplicate array because I am updating the result, and I'm reusing nums. We need nums in the same state on this iteration as well, so that's why I need a new result. This is not an extra, like this is an extra space complexity, but the output array does not count as extra space, right? So this will be my result. So we have the prefix, we are updating the prefix value and updating our result. Then suffix, we are starting from I greater than or equal to 0. Okay, right, cool. Right, let's run this. Okay, solution got, the test cases are passing. Let's submit this. I think the performance of this would be better, I hope. So if you see last one, if you see, the runtime was also greater. There are obviously double iterations and all, but in this case the performance is at peak, right? Okay, I hope this solution makes sense to you. Thanks for watching. Let's meet in another video.